So hello and welcome to part 2 of the Pixel Soccer Global Tournament Making Of. Today we'll start actually using Visual Basic to program. And we'll just start a standard exe. And of course you'll get a simple form. And the first thing we'll do, of course, modern games run in full screen mode, and there are two kinds of full screen modes. There's actually a real full screen mode which you can force through Windows API calls. This is the case if you press Alt-Tab and your game minimizes and weird flickering happens on the screen before the other windows come up. And there is this other possibility to just take a borderless window and make it the size of the screen, which will be like a normal window, but nothing else will be visible, of course. And I think for us this is suitable because our game won't be too hardware intensive, and therefore there's no need to deal with real full screen in this case. So we'll call this frame game for starters, and we'll just set the border style to nothing, borderless. And as you can see in the editor, it's just a borderless gray blob now. And so if we go into form load and just say move, like me move of course, 0 screen width, screen height. So if we do this, what will happen is if we start, the window is moved to the coordinate 0, 0, which is up here where the mouse pointer is, and it will just be as big as the screen. So let's press play, and you see everything else vanishes and our window is now borderless window mode full screen. That was easy, actually. Works like I expected it to do. And if we press Alt-Tab, we can easily switch between other tasks. Okay, so a quick warning here. Screen, this object in Visual Basic is not actually screen, but it should better be called, I don't know, desktop or something, because if you have more than one screen, screen width and screen height will actually be the width and height not of one of the single monitors. You could probably think it would be the primary one, but no, it's not actually, and also the coordinates are not. It will be the whole desktop space. So if you have two monitors left to right, 0, 0 will be the coordinates top left of the first monitor, and width will be the width of both monitors combined. Height will probably be okay, but in the long run we'll actually have to use the Windows API to get the real screen width and height of the primary display device, and we'll do in the long run. We'll just optimize this to run on other machines, but right now, I mean, it suffers for us to test some things out. Well, this is not actually something only indie developers suffer this problem, but AAA titles suffer it as well. I mean, even like a game like Bethesda's Skyrim, Elder Scrolls V, even they are dealing with this issue, and you can always recognize this if you have multiple monitors and it's not tested probably in the software. You can move the cursor out of the confines of the actual game or software window, and if you then click somewhere, the window will minimize, your game may crash, or you will die while the game is minimized or something, because the cursor was not confined to the borderless window. We'll do this later. We will confine the cursor to the window. I've written a small program called Primary Lock back in the day, which I shilled out on the Steam forums and stuff for free, where you could start a program and it would recognize which window was active, and it would confine the cursor to the size of the window, so you couldn't move out the cursor as long as the program was running. And it worked pretty well for many games like Commander and Conquer games and Skyrim, as I mentioned earlier. It was cool. It was a neat little program. You can Google it. It's still available on my homepage, and it really helps in some cases. And we will implement some kind of similar logic into the game later. But for now, we'll just stay with this. So, how do vintage games work in general? Well, most of them use one single thread, and this is good because people who have used Visual Basic know that if you want an application that runs smoothly and won't crash, you should probably stick to using the main thread and not play around the Windows threading API, except if you program a lot of C DLLs to deal with it and to help you out, or to use ActiveX files. So we'll try this. We'll see how it works out. And so for now, how do we start the main game loop? Well, I personally like for starting things after the window is initialized completely, I put a timer on the window and call it TMR start and disable it, and put an interval of 100 milliseconds. You can do 50 or 200, it doesn't matter too much, but it should be around 100 milliseconds. And when the form load event is over, we will enable the timer, and in the timer, hello? Yeah. We will disable it at once because it is supposed to run one time only. Enable false, of course. And then we will run our game loop. And run will be the sub or procedure function, whatever you want to call it. It will actually be a sub because it won't return any value. Private sub will run. And we will put the most simple loop of all times inside, do loop. Well, that's the very, very basic Visual Basic loop. And let's open the direct window, because it's a fancy window down here where you can type commands directly. For example, you can type a question mark and then screen width, and you will see the actual screen width at the moment. And this is of course not pixels, but instead it is TWIPs. TWIPs is well, what Visual Basic likes to calculate window and control sizes in, and printer coordinates and stuff. And we'll deal with it. It's pretty easy to calculate pixels from TWIPs, for example, by doing screen TWIPs per pixel X. So then you see that my actual display resolution, since I'm only using one monitor, is actually 1920. And yeah, this is the direct window. It's pretty useful if you haven't used it or if you're a beginner. And well, that was just a bit of side information. On the other hand, let's go back to our game loop. Yeah. So we have do loop. What does it do? Well, it just creates an endless loop and nothing will happen. And to allow Visual Basic to redraw windows and to react to events that happen in the background, you should actually, in every loop that is called looped through multiple times, you should put in do events, which will take care of this problem. And so Basic will get, if do events is executed, Visual Basic will get time to do all kinds of background tasks that otherwise actually won't be done anymore. So your window won't be redrawn and funny stuff like that. So now this is fancy, but with a loop like that, and many old games suffer from this nowadays, from this illness, I suppose you can call it that. If you try to run an older game, a DOS game or a very early Windows game on your fancy new computer, like I am personally having using a AMD 6-core CPU and 4 gigs of RAM here. What will happen is that the old game runs much faster than the creators intended it to, because the computer is so much faster than the computers that were state of the art when the game was created. And to illustrate what I mean, I will create a loop count, and I will count how much loops our game can manage in 1 second. 1 second is a pretty important number regarding games, because redrawing the game, updating the game screen, is pretty much done in frames, and frames are measured in frames per second normally. So if you're interested in video, DVD formats and stuff, or in gaming, you know that around 30 frames per second is thought to be enough to fool a human eye into thinking that movement is smooth, and there is no stuttering or no effects that hurt the eye or that look weird. And therefore 30 frames per second is something you should actually try to reach with your game. And therefore actually you could say that every game loop that happens, your window will be redrawn. So we will probably later on put here stuff like do something. So the game is advanced 1 step. There are calculations of the AI. There will be controller input, either by keyboard, by controller, by mouse, whatever, of your player, and they have to be calculated. There has to be done something to calculate what is happening in the next redrawn stage of your game. So there will be do something and then redraw window, for example. And in the loop we have now, nothing is controlling how often the window will be redrawn. And if there is no controller instance in this case, that will simply mean that the window is redrawn as often and as fast and as quick as the PC is able to calculate. And I have a rather fast PC, and if I let it run this way, it will probably reach, I don't know, 100,000 frames per second without something to do in between. And to count it, we will actually count for 10 seconds to get a good look at it. So I do dim start time as date. Start time is now. Okay, so let's see if date diff, absolute date diff. I always use absolute, it's easier that way. Date diff. Sorry, my phone is ringing. I'll be right back. Sorry, my phone was ringing. So back to dateDiff. dateDiff tells you the difference between two dates, actually. Two dates, and I will do dateDiff seconds from start time to now. And this should be bigger than 10 seconds. and if it is, just exit do. So the loop will cancel after basically 10 seconds. And well, let's say actually 9 seconds. Yeah, because it starts, the difference starts at 0. It has around 1 second of time. Yeah, this is better. 9 seconds will be probably the right thing to acknowledge here. And then we will do debug print, which will output something down here in the direct window. Debug print loop count divided by 10, and this will show us how many loops my computer is able to handle without like something to regulate. And let's press so our program should end after that. Unload me will suffice. Unload me will kill the main window, and if the main window is killed, Visual Basic will just exit. Okay, so let's see what happens. We wait for 10 seconds, and after that we'll have a feeling about how many frames per second my computer is able to do without anything to calculate in between. Okay, so this means it manages to do around around 200,000 frames per second in this case. So what can we do? I told you earlier that 30 frames is an okay thing to reach. We could use 60, I don't know, maybe we'll do 60, it won't hurt. Okay, so 60 frames per second, and 1 second basically means 1,000 milliseconds. So we go here and say 1,000 milliseconds divided by 60 frames means that every 16.5 milliseconds there has to be a screen redraw to reach approximately the right amount of frames. I would go with 17. So how do we tell it to wait 17 seconds, milliseconds of course, sorry, before the redraw is happening? Well, there is a nice API in Windows which allows you to do something like that pretty easily. And I'm using a neat little program here called API Viewer. It is available at activevb.de. You can download it, it's for free. You can donate by PayPal, and it's much better than the API Viewer that comes with Visual Basic. Because the IDE is great and you have a lot of options here, and you can search and stuff. You can, like, the output is formatted pretty good, and what we are looking for now is sleep. SleepX we won't need at the moment, we will use sleep. And you see we just take it here and cut it out and then insert it into our form. And you see that it's a sub, we don't have to take care of anything like return values, API errors or whatever. It will just sleep, it's nothing special. So before the do event we will put a sleep command for around 17 milliseconds. This will tell Visual Basic that it's actually a long value and not an int. I always use it. I mean, it is actually, it will to a certain extent optimize your code, because Visual Basic doesn't have to recognize if it's a long or an integer by looking at the function, which forces you to pass a long value. This way it will already know it's a long value, and it just spares some expense on Visual Basic's part. Okay, so now we'll have this, and now we'll see how long or how many frames we will get now. Waiting 10 seconds, so let's start the program for 10 seconds. Of course you will never reach 60 frames exactly, mainly after we implement logic and code and redrawing, because this will take time. So we see that with this value we will now get around 54 frames per second, which is good, and it will probably drop to 45, I would guess, if we implement some logic. But yeah, well, of course we'll do that later. But this was probably the first interesting aspect, that developers have to put boundaries on their games. Otherwise, they will just run friggin' fast on better computers. And in this case, it was a good step in the right direction for us in this first actual hands-on Visual Basic. And next time we'll talk about drawing stuff onto your new borderless window. Basically what double buffering means and why we use it. And I hope you enjoyed this part, and you always can give me a thumbs up. I appreciate it. And I appreciate if you watch the next part as well, when we will learn the secrets of double buffering your output. That's all for now. Hear you next time. Bye.